Hello everyone, this is Ms. Chelsea and today we will be discussing pure substances and mixtures. Our standard for today is S8P1A, which is to develop and use a model to compare and contrast pure substances, which include both elements and compounds, as well as mixtures. Now, as we work through these slides and learn a little bit more about pure substances and mixtures, I want you to keep in mind the following question. So pretend you have a container of salt and a container of trail mix. How could you physically separate the sodium and the chlorine from the salt? And how could you separate the pieces in the trail mix? To tackle this question, we first need to know how to classify different types of matter. Atoms are the building blocks of matter. An atom is the smallest unit of an element that maintains the chemical properties of that element. They combine with one another to make different materials. A molecule is two or more atoms that are chemically combined. If these two atoms are the same, we have an element. For example, O2 is two oxygen atoms put together. It is the element oxygen. Now, elements are made up of one or more of the same type of atom that are chemically combined. Elements cannot be broken down into simpler substances. Keep in mind that all known elements are found on the periodic table of elements. These include gold, whose chemical symbol is Au, and sulfur, whose chemical symbol is S. If you have two or more of these elements bonded together, then you have a compound. Compounds are molecules that are made up of different elements that are combined chemically. Compounds have a fixed composition and their properties are different from the atoms that make them up. For example, sodium tends to react violently with water to explode. However, when it is attached to chlorine, a poisonous gas, then it forms table salt, which you need to eat in order to survive. Now, keep in mind a chemical bond is the force that holds the atoms together. So, other examples of compounds include water, H2O, and carbon dioxide, CO2. Notice how for each of these I give a number of each type of atoms unless there's only one of them. So they must be combined in that specific ratio. Now, mixtures, on the other hand, are made up of elements and compounds that are not chemically combined with one another. Instead, they are physically combined, for example, through mixing. Consider pizza. Pizza is made up of different ingredients and toppings that are physically combined. You knead the dough, you add on the toppings, so it's mixed physically, combined physically. Salt water is another example. You can stir the salt and the water together to create salt water. And then it can be separated physically as well by evaporating the water, which leaves behind the salt. Keep in mind, mixtures are physically combined and can be physically separated. They are not chemically combined or chemically bonded. Now, let's try identifying each of the following examples as an element, compound, or mixture. First of all, hydrogen. Hydrogen is found on the periodic table, so it is an element. Glucose, or C6H12O6, is a combination of three different elements, carbon, hydrogen, and oxygen, in the specific ratio 6:12:6. So it is a compound. Milk, on the other hand, has various different compositions. You can get whole milk, 1%, 2%, or fat-free, and that's just for dairy milk. So milk does not have a specific ratio, therefore it is a mixture. Cookie dough as well is a mixture because different people have different recipes for cookie dough. Plus, you can add different add-ins to it, like chocolate chips or nuts. Salt, on the other hand, is NaCl. It's one sodium and one chlorine, making it a compound.